Greetings, sophomore chemistry. We've showed you a lot of stuff inside of chemistry, and we're going to show you a little bit more on how you use Sage Modeler. A lot of you have stumbled into this problem with your models of you want it to indicate going from one zone to another zone, but not as a static, but more like dynamic. Think the stuff that we were doing earlier on in the year where we were talking about, smell traveling over time and when people could smell particles, and how we modeled that was with motion lines and a dynamic model, like the storyboard approach. So today I'm going to show you how to kind of take that storyboard approach to modeling into Sage Modeler. So we've never asked you to actually just go to Sage Modeler and play other than like at the real beginning of the work with it. So I am going to show you how we just type in Sage Modeler into our Google search and we go to this sagemodeler.concord.org. And then there's a launch Sage Modeler up there. There's also another button down in the lower left. We're just going to launch it. So here we go. We are going to create a new document. And today we're going to talk about the zoo. All right? So I'm not going to add any images to this because our firewalls are up and I can't get images nice, pretty, and easy like you guys can at home. But please feel free to explore images just like you did before. Now understand, I don't want you to give us this model with the assignment. I want you to give us whatever you want to play with dynamic modeling. But we're going to talk a little bit today about two situations. Okay? We're going to talk about free monkeys and we're going to talk about caged monkeys. All right. And we want to know how this relationship between free monkeys and caged monkeys actually influences chaos at the zoo. Okay, or the amount of chaos at the zoo. Maybe a space. Amount of chaos at the zoo. Okay, so yeah, we could draw some arrows here, but we would still not get the overall picture because we'd be drawing arrows back and forth here. We wouldn't know how it influences this one down here. It's really hard to kind of do this because we either do it in one direction or we do it in the other. And then if we try to do it in both directions, things might get a little weird because the one thing we know about this situation is that we have a finite amount of monkeys. A finite amount. So we're going to explore this gear, this third button down called dynamic time-based simulation. Because we're going to talk about how monkeys can free other monkeys, and we're going to talk about how we might be able to get the monkeys back in the cages. So right now, I know that there's a relationship between free monkeys and caged monkeys. Okay? I also know that I have a limited supply of them. So I'm going to go click on one of these, and then I am going to grab the ruler, and I'm going to turn this into a collector. Okay? And then I'm going to grab free monkeys, and I'm going to do the same thing because I have a limited amount of monkeys. Now, what do I know? I know with the arrow, if I click on this now and then click the arrow, I have different options here. And I know that if a caged monkey is doing what with free monkeys? Well, a caged monkey that is escaping is adding to free monkeys. All right. But then again, a free monkey is adding to a caged monkey if it's caught. No, that's not right, because we are transferring them from one zone to another. All right? We're transferring them from one side to another. I want you to see there. We'll pull it down here. Maybe pull this one. There. That'll work. I want you to be able to see flow and flow lines. So, okay, now we got to talk about how they're being transferred. Okay? So, we need to talk about what influences these. We know that the caged monkey is being transferred to free monkey, and the free monkey is being transferred to caged monkey. And if I hit simulation, you know, I can raise the number of caged monkeys and raise the number of free monkeys, but not a lot is really going on. But I could also, you know, increase the flow of free monkeys to caged monkeys and vice versa. And when I do that, you'll notice that the shapes of those graphs are changing as well. Okay? But we have something else that we can add in, because that's really not going to tell us about the amount of chaos. We need a way that we are actually going to trap the monkeys again or let them go. So we are going to introduce zookeepers. Okay? Now, zookeepers don't affect the caged monkey and the free monkey, but they affect the flow rate of them. They help prevent caged monkeys from going free, and free monkeys they put back in the cages. So if I click on this valve and the arrow, I can actually define that an increase of zookeepers will cause the flow of free monkeys to caged monkeys to increase by, okay, we'll just say by about the same. 1 monkey per zookeeper. Okay? And then an increase in zookeepers causes the flow of caged monkeys to free monkeys to decrease. So I'm not just changing the flow on one side, I'm changing the flow on both sides. Okay? So now let's see what that does. If I have about an equal number of caged monkeys and free monkeys, and then I lower the amount of zookeepers, we notice that the free monkeys can release the caged monkeys, and we got more caged monkeys getting out. And the free monkeys will be limited by the amount of caged monkeys that I have initially. You'll also see that the flow of monkeys from caged monkey to free monkey is increasing, but the flow of free monkey to caged monkeys is bottomed out if I have no zookeepers. But if I increase the zookeepers, we can see that there's this like inflection point where the increase of free monkeys and the decrease of caged monkeys flips to going the other way. And I add more and more zookeepers, and I can actually get those caged monkeys in there, and I can even get them in there faster, and that's what's happening with this line there, is it's talking about time and the speed at which I'm getting those monkeys back in. All right, so what else can I do? I need to talk about chaos, though. I know that the amount of chaos is going to be influenced by both of these two groups, the free monkeys and the caged monkeys. So the free monkeys, an increase in free monkeys causes amount of chaos at the zoo to increase, and we'll just say by, you know, by about the same. And an increase in caged monkeys causes the amount of chaos at the zoo to decrease, though, and we'll also say by about the same. Okay? So I've just tried to account for all these variables. We can add the why we think so's in there, and I'd like that if you did that inside of your sample model. But now I can simulate again. And notice, I have a high amount of zookeepers, and look at what happened to the chaos at the zoo. It's almost bottoming out. But if I decrease the amount of zookeepers to nothingness, the amount of chaos that was there at the beginning of the day is going to increase even more as more monkeys get free. And then there will come a time when I can see this flip zone where I've maximized the amount of chaos at the zoo because I'm not catching or freeing any more monkeys. The zookeepers have kind of made this a static system, but then I keep making steps, keep going up, and I can decrease that amount of chaos and decrease it at a faster rate too. So ladies and gents, this is dynamic modeling. Playing with collectors, where is it coming from? Where is it going to? Think about that as you think about your current models that you're creating to model intermolecular forces and phase changes, and see how might you incorporate a dynamic model into that system. But play. Make some arbitrary system like caged monkeys and free monkeys and zookeepers and chaos at a zoo, and just play around. And it doesn't need to look exactly like this. You know, you can have it influence the valves, you can have it not influence the valves. We just want you to play around with dynamic modeling and show us what you can create, and just anything will do. So I'm going to show you, once you are done playing, you're going to come up here and you're going to save it to your Google Drive. Okay, and I'm just going to call this Monkeys. All right, and then what you're going to do next is you're going to share, and you're going to get the shared link. You're going to enable sharing. It's generating a link. I am going to copy that link, and then I'm going to go into the assignment Sage Modeler Play. You're going to go to your turn-in, and then you're going to paste that link inside of there to turn in. Okay? So ladies and gents, have fun, play with monkeys, play with money, play with, popularity, driver's license, whatever you want to, whatever you think you can turn into a dynamic system, go ahead and do it. Show us what you can create. I can't wait to see what you're going to come up with. All right, guys, have a great weekend.